All right, today we're going to talk about Chapter 5, Lesson 9. This is all about similar figures. So, similar figures are figures that are the same shape but not the same size. Now, what I mean by that is that they're not both just regular triangles. They're not both rectangles. They're not both squares. They're not both circles. What I mean by similar or same shape is that they are the exact same shape. That they have corresponding sides, they're proportional, and angles are all congruent. Now, those are the two different stipulations in order to say if a figure is similar to another. So corresponding sides are proportional. A corresponding side means the same side on each shape. The other one was corresponding parts, or corresponding angles, are congruent. Now, congruent is just a fancy word that we use in geometry to talk about if things are equal. We like the word congruent, though, in geometry. So let's look at example 1. Let's look at it specifically, part A of example 1. So it says these figures are similar. Find each missing measure. So corresponding sides are going to be this side length worth 3 and this side length worth 12. They are the exact same side on two different shapes. Now, we said earlier that they are proportional, so I'm going to write a proportion. The first part of this proportion is going to be the ratio between these two similar sides, so 3 to 12. The next part is going to be between these two corresponding sides, because this is what I'm looking for, and this is the side that corresponds to that. So I started with small, went to big, so I'm going to start with small again and go to big. Now, when I go ahead and do the cross multiplication, I have 12 times x, which is 12x, and 3 times 33, which is going to give me 99. If I divide both sides by 12, I get x equals 8.25. Let's look at part B here now. Now, part B, again, we're looking for x, which is right here. The corresponding side is this side length of 24. So I'm going to start writing my proportion that way. So I have x over 24. I started with this figure, so I need to keep going with this figure. These are the other two side lengths I know, and they are corresponding to each other. The 5 corresponds to the 10. They're in the same place on different shapes. So 5 was on the small one. I started with small, so I'm going to continue with that. So I have 5 to 10. If I do the cross multiplication, I have x times 10, or 10x, equals 24 times 5, which is 120. To get x all by itself, I divide both sides by 10, and I see that x equals 12. Some of you might have been able to see this. Between 5 and 10, those are 5 is half of 10, or 10 is double what 5 is. So if I'm going to do that, what is half of 24, or 24 is double what? And that'd be 12. Now, another thing that we can use is actually something called scale factor. So you can use scale factor to determine missing side lengths because the scale factor is the ratio of corresponding parts in similar figures. Now, that can be very, very helpful for us to use because we've already known how to do scale factor. So example 2, it says nested boxes are a series of boxes that fit inside one another. The faces of a larger box are similar rectangles. So a face on a larger box is a length of 24 centimeters and a width of 13.5 centimeters. If the width of a face on a smaller box is 9 centimeters, what is the length of the smaller box? So first thing we need to do is find the scale factor. Remember, scale factor is a ratio of corresponding parts. The only thing that we know about the smaller box is its width. So I want to know what the width of the larger box is too. So the width of the smaller box is 9 centimeters, and the width of the larger box is 13.5 centimeters. If I get that all the way down, I will find out that the scale factor is actually 2 to 3. 9 divided by 13.5 is 2/3. Now, I'm going to use that to figure out the side of the larger, or the larger length. I'm going to use this and multiply by the larger length to find the side length of the smaller box. So I'm going to multiply by 24. When multiplying by fractions, I multiply numerators together and then denominators together and simplify. So 2 times 24 is 48. 3 times 1 is 3. If I simplify this, there's a common factor of 3, and I will get the side length of the smaller box to be 16 centimeters. If you have any questions, please let me know. Otherwise, this is the end of Lesson 9.